Let's take a look at another example here. What I want to do is I want to find the coordinates on this plane that's closest to the point in 3 space 1, 2, 3. So what this really means is I want to minimize the distance. So what I need to do is talk about, obviously, pull out the distance formula here. So the distance is going to be equal to the square root of x minus 1, there's my 1, squared, plus y minus 2 squared, plus z minus 3 squared. So what this means is I need to minimize this. Well, I know that x minus y plus z, let me clean that up a little bit, x minus y plus z equals 4. That implies that z equals 4 minus x plus y. The reason that's important is going to go substitute this in here, so I now have this function of x and y. So distance is going to be x minus 1 squared plus y minus 2 squared plus z is going to be 4 minus x plus y minus 3 squared, which obviously I'm going to combine those terms, make it a little bit easier to deal with, which is going to be the square root of x minus 1 squared plus y minus 2 squared plus this is going to be 1 minus x plus y squared. Now, to minimize this function, it's the same as minimizing d squared. D squared is going to be a little bit more manageable, so I can get rid of this radical. So minimizing the distance squared is the same as minimizing the distance. So I can minimize this function instead. So this is actually d squared, and I'm going to call this function f of x, y. So this is what I'm going to use to take my partials of. So if I take the partial with respect to x, here I'm going to get 2 times x minus 1. This is going to be 0 with respect to x. And this would be plus 2 times 1 minus x plus y times the derivative of the inside, which is a negative 1. So there's my partial with respect to x, which this negative I would carry out here and put it out here. So what I have is, let's see, 2x minus 2 minus 2 plus 2x minus 2y, which will combine to give me what? 4x minus 2y minus 4. So this is my partial. Now notice here I need to set this equal to 0, but I can't because I have x and y's. That's okay, I'll come back to that in just a second. So now let's find my partial with respect to y. This is going to give me a 0, and then I'll have a 2 times y minus 2 plus 2 times 1 minus x plus y times 1. So I have, let's see, 2y minus 4 plus 2 minus 2x plus 2y. Let's collect like terms. Where's my x? I'll put my x first. Negative 2x. So it takes care of that. Plus 4y minus 2. I also need to set that equal to 0. The way I'm going to do that is I'm simply going to have to solve the system. So let's go ahead and go back to algebra, your basic algebra class. Minus 4, go set this equal to 0, set this equal to 0, and solve it. So if I multiply the bottom by 2, I'll have a negative 4x and an 8y, so the x's drop out. So I have an 8y minus 2y, which will give me obviously 6y. Negative 4 minus 4 gives me minus 8 equals 0. That implies y equals 8 over 6, or y equals 4/3. Well, if y equals 4/3, I can now go back and back solve, and I'll have 4x minus 2 times 4/3 minus 4 equals 0. And then that gives me 4x minus 8/3 minus 4 equals 0. So that's 4x minus that's going to be 8 and 12, so that's minus 20/3 equals 0. So 4x equals 20/3, which means x equals 20 divided by 4 times 3. That gives me 5, so it looks like x equals, 5/3, not 5/5. 5/3. So now that I have x and y, I can come back and solve for z. So right now I have x equals 5/3. I have y equals 4/3. And then when I come back up here, where is it? Right here. And I solve for z, I'll end up with 11/3. So now I have the critical point. Now, by the mere physical nature of this problem, I know those coordinates are going to give me the minimum, but we can verify this using the second derivative test, which is probably a good idea. Now, up here is the partial with respect to x, so I need the second partial with respect to x. That's going to be 4. Here's a partial with respect to y, so I need the second partial with respect to y. That is also going to be 4. And I also need the partial with respect to x and then y. Well, that is this with respect to y, which is going to be a negative 2. So now I have all the pieces that I need. Remember the second derivative test. To use that, what I'm going to look at is I'm going to say d equals the second partial with respect to x times the second partial with respect to y minus the partial with respect to x and y squared. And that's going to equal 4 times 4 minus a negative 2 squared. That's 16 minus 4, which I don't care what the number is. All I care about is that it's greater than 0. And note that f(x) is also greater than 0. Therefore, these coordinates this is actually a min.